Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In today's video, we are going to do an example 11.8 from the Shikli Mechanical Engineering Design book. Okay, for in doing this example, I hope you have the book with you because we are going to refer for some tables inside the book. Okay, so let's do this question. Okay, the shaft depicted in figure 11.8a, which is I will show in the next slide, it carries a helical gear with a force of 3980 Newton, radial force 1770 Newton, and thrust force 1690 Newton at the pitch cylinder with directions shown. Okay, in the next slide. The pitch diameter in the gear is 200 millimeter. The shaft runs at speed at 100 revolution per minute, and the span, as right, between the direct mount bearing is 150 millimeter. Okay, so the design life it will be 5,000 hour, and on application vector, if one is appropriate, its reliability of the bearing is set to be 0.99. Select suitable bearing. Select suitable single row taper roller Timken bearings. Okay, just remember from the previous video, we say that Timken has its own standard. Okay, if you remember one equation, equivalent force that have the uh, standard equivalent force you have learned before. Fe equals to xb k fb I plus uh, something k something like that. So okay, uh, for Timken is suggested as 0.4 fi plus k fr, something like that. It is suggested by Timken company. If you are using Timken bearing, you may find this equation is related to you. Okay, so we see this. We see the figure given is the figure 11.18. External essential geometry of helical gear and shaft length dimension in millimeter loads given. Okay, you can read all this. Uh, Forces in xy plane and forces in xz plane. Okay, you see here, where is xy? Okay, this is xy plane. Okay, this is xy plane, and this xy plane here. Okay, this is xy plane, x, the x. Okay, this is xz plane. Okay, x and z plane is three dimension. You try your best to imagine it. Okay, so we want to find the suitable bearing for this arrangement. Okay, for direction from xz plane in figure 1118, RZA radial, okay, 3980 over 150, you get 1327 Newton. ZB 3950 100 over 150, you get 2953 Newton. So it times the length, 50 is the length, 100 is also the length. 3980 is given, and 150 is the total length of the arrangement. Okay, trace back during this question and all of the question. Trace back when you get the numbers. Okay, uh, try your best to trace back where you get the numbers. Okay, so reaction from xy plane in figure 1118 are this. You put the value here, you put the value here, you get 1717 Newton and 53 Newton. Okay, and then for the radial loads, the vector addition of r y a r z, and respectively this is radial load for A, and this is radial load for B. You see this equation, you see, do you familiar with this equation? It is a Tyron Pythagoras. The Tyron Pythagoras, you remember when you learn in mathematics, Tyron Pythagoras equation. Okay, this is the equivalent, the radial load FA and B. If, I'm sure you are familiar with this equation, Tyron Pythagoras. Okay, you get this equation, the equivalent load for radial load and everything. And then we go for the trial. This is what different between the normal mathematics and the trial. And because you have to do iteratively until you get your satisfied answer. Okay. Okay, trial 1 for direct mounting with direct mounting of bearing application with standard thrust. The shaft, the squeeze bearing is bearing A, labeled at figure 11.8A. Okay. Okay, in the previous video, I have explained what is a squeeze bearing. Uh, Remember, if you have the two bearing, if you have a bearing, you want to put a shaft inside a bearing, inside two bearing, one and two. When you put the first one, you will be hard and difficult to insert the first one, and it is easy to insert the second one. Naturally, the hard part is the squeeze part. Okay, this normally and naturally it will accept um, force. It will accept the thrust load more than, let's say, it is A, this is B. It will accept more thrust load at point A and then point B. Normally like that. Okay, you can refer to the previous video about the squeeze. I have tried my best to explain what the meaning by squeeze bearing. Okay, using K as 1.5 as the initial gas for each bearing, the initial load for R like this. Okay, K is one equivalent to 1.5 using Timken equation. Okay, you can initially uh, you can you can randomly guess any value, and then you can get your answer, and then your answer is justified. Okay, acceptable, is not satisfied, do it again and again until you get your answer satisfied. Okay, so this is the induced load from bearings FIA. This is 0.47 FRA per KA. 0.47 is come from the Timken suggestion. Timken, if you using the Timken bearing, you should use 0.47 as the value to replace the value of XV. Okay, remember in the earlier pages of the slide, you is a XV. Okay, XV replaced with 0.4. Okay, there is a one table 11.1. Is not, I'm not mistaken. Table 11.1. It has the table for X value and V value. Okay, since FIA is clearly less than FIB and FAA. Okay, bearing A carries the net thrust load and equivalent 11.9 is applicable. Therefore, uh, randomly equivalent loads are this value. You can put all the value, you trace back to the number, you get 494651 Newton, and FE equal to FRB 2654 Newton. The multiplied the rating life is XD, rating life 2.67. Okay, and estimate the RD. RD equals to this 0. Reliability, the question says that reliability is 0.99. Okay, so as 0.995 for each bearing. For bearing A, catalog entry theta should be equal than this. Okay, why reliability, again, why reliability must be 99%, equal to 100%. Okay, because this arrangement you want to use it for a long time. It's not like a toy, it's not like a things bearing, normal bearing that you may open and close, do maintenance regularly. No, this is attachment that you want at least you do the maintenance is taken for the long period of time, then you can, then you do maintenance. If possible, you are not, do not bother about doing the maintenance. Okay, uh, this is why you put reliability 99%. Okay, so the C10, the catalog rate for C10 is 11486 Newton. Okay, from the figure 1150, tentatively select TS 1510. That is why I don't put the table inside here. I suggest that you have uh, the book beside you, so that you can see figure 11, 15. Okay, because you can select what it meaning by TS1500 cone, and this is the number of cone that represent the cone. Okay, then you can get all the value, the parameter, the dimension of the cone inside this catalog. Okay, so for bearing B, equation 1110, the catalog entry system should equal or exceed C10, its value. Tentatively select the bearing identical to bearing A, which book SKB S01.67, C10 equals to 2100. Okay. And then try the answer may not satisfy you, okay, for some reason. Okay, try to repeat the process with KA equals to KB 1.67. The value you get from the last equation, you can refer back to the previous video. And you can get this answer 611. You put the answer 611 and 747, and since FIA is less than FYB and FAE, application 11.9 is still able. What is this? Okay, it shows that the truss bearing, you have the both bearing A and B. Okay, A and B, the truss. This is meaning by you select this bearing give accept more load. Okay, accept more load. This is what because the FIA less than combination FIB FIA. So using this, it justify that the bearing at this side it, receive more load. Okay, one of the bearing receive more load. Okay, so FE, you can put all the value here, you get 4938 Newton, and FE equals to 2654 Newton. Okay, for bearing A, the corrected catalog entry C10 should equal or exceed this value. 1, 2. Okay, this C10 value, remember from equation 1110. Okay, this is the normal equation for 1110, so 12,000. Although this catalog entry exceeds slightly the catalytic selection for bearing A, we will keep it since the derivative of bearing B exceeds 0.995. The next section, we will quantitatively show the combined derivative of bearing A and B will exceed the derivative goal 0.99. Okay, so bearing B, okay, Fe equals to FRARB 2654 Newton. So C10 equal to this value, you get 6554 Newton. Okay, select the code, select code and cup respectively. You can must refer to the table. The table. I suggest you have the book with you, beside you. Okay, for both bearing, note the figure 11.4 effective loading center located at A equals to negative 5.8, which is 5.8 into the cup from the back. Okay, when you put the shaft, it will 5.8 millimeter from the cup. Okay, so the shoulder to shoulder dimension should be 1.0 minus 2 times this, and you get 138.4 millimeter. Okay, iteration to find the catalog relative the portion of the equation analytical need not to be re-entered or calculated on each time. That's the explanation to do this question. To select the suitable taper bearing. In the end, the answer you get, you refer to the catalog and you get the answer. Okay, so that's all for this video. We see you in the next video on 1110 design assessment for selected roller contact bearing. Thank you very much.